to explore ourselves in this field. And yes, surely these 5 days will be very useful to us and would help us throughout. Now, every day starts with a small prayer to our worthy God. And here we'll play a small Saraswati Vandana for the session to start.
या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा विचारसार परमा आद्यां जगद्व्यापिनीं वीणा पुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहाम् हस्ते स्फाटिकमालिकां विदधतीम् पद्मासने संस्थिताम् वन्दे तां परमेश्वरीं भगवतीम् बुद्धिप्रदां शारदाम्
Now I would Now I would request our worthy director, sir, Dr. Ravish Sagar, to welcome all the presentees over here. Director, sir.
Am I audible, ma'am?
Yes, sir.
Good morning to one and all. And first of all, foremost, happy Teachers' Day to all the participants, all the guests, everybody. The most demanding and most demanding and upcoming field and maturing field in computer science today is machine learning through Python. Start to till end of life, human keeps learning. Humans are trying to shift their load of knowledge to machines. What actually needed is implementation of knowledge without error. Machines are the only options for this. Anybody can teach you. No matter the age, the experience, anybody can teach you. And that person can become your teacher. Today is Teachers' Day and the best day to spread knowledge. What could be the best day other than today for a teacher to teach human to learn how machine learns or how we can teach machines? I, Dr. Ravish Sagar, Director of Banarsidas Chandiwala Institute of Information Technology, really thankful to Dr. Minakshi, Dr. Pooja Sapra, Miss Nidhi for accepting our invitation and joining this event as a speaker. One more renowned personality is with us. She is Dr. Mamta Mittal. I really honored and delighted to share platform with all these dignitaries. I express my gratitude to all the experts for accepting our request. I would like to congratulate my team for scheduling such an event in a very short notice. I, on behalf of BCIIT, really would like to thank our participant who believes on us. Without further delay, I request Madam to take charge and move ahead. Thank you, ma'am. Thank you.
Thank you, sir. Thank you so much for joining us, sparing your time for us. Now, I would request Dr. Sushma Bahuguna. She is the MCA coordinator of Banarsidas Chandiwala Institute of Information Technology, to take over and introduce BCIIT to us. Over to you, ma'am.
Thank you, Sonia ma'am. Am I audible?
Yes, ma'am, you are audible.
Thank you so much. Greetings to everyone and wish all a very happy Teachers' Day 2022, September 5th. As we all know, the birth anniversary of the second President of India, Dr. Sarvapalli Radhakrishnan. To honor his life and work and his approach towards education and student, the day is observed as Teachers' Day in India. Learning has no end, as quoted by Albert Einstein. Wisdom is not a product of schooling, but the lifelong attempt to acquire it. Intellectual growth should commence at the birth and cease only at the death. I, Dr. Sushma Bahuguna, thank Director BCIIT, Dr. Ravi Sagar, and Ms. Sonia Batra, the event coordinator, and the entire organizing team for giving me this opportunity. It is truly an honor to welcome all eminent speakers and faculty participants for 5 days faculty development program on machine learning using Python, organized in online mode by BCIIT. One of the advantages of online mode is that it is not limited to the boundaries of an institution and has eliminated geographical limitations, as we will witness in this event. Banarsidas Chandiwala Institute of Information Technology was established in 1999 to run Masters of Computer Application program. It also started with its 3 years Bachelor of Computer Application program in the year 2021. The institute is affiliated to Guru Govind Singh Indraprastha University, Delhi, for awarding the degree and is approved by All India Council of Technical Education, Ministry of HRD, Government of India. The institute is established under the aegis of Sri Banarsidas Chandiwala Seva Smarak Trust Society, a charitable society working in the field of health and education since 1952. The institute is student-centric, where all faculty members are always alive to the needs of the students and are focused to develop them to the top-class software professionals. The FDP schedule is to enrich the knowledge, strengthen the professionals, development of faculties through interaction with eminent personalities from academics, experts in their own domain, as knowledge sharing always improves the teaching, learning process and benefits the society. In learning, you will teach, and in teaching, you will learn, said by Phil Collins. And today, we are talking of artificial intelligence, that is essentially the simulation of human intelligence. Artificial intelligence, a technology that enables a machine to simulate human behavior. Machine learning is a branch of artificial intelligence and computer science which focuses on use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. We simulate the natural intelligence in machines that are programmed to learn and mimic the actions of humans by building certain models. I extend my warm welcome to the renowned speakers who took out their valuable time and joined us to be the part of this FDP. Dr. Meenakshi Memoria, Dr. Pooja Sapra, Dr. Anu Taneja, and Ms. Nidhi Grover Raheja, the speakers of 5 days FDP. Guest Dr. Mamta Mittal, Program Anchor, Data Analytic Department, Delhi Skills and Entrepreneurship University, Shakurpur, and all the participants present for the FDP from across the country. Dr. Meenakshi Memoria, presently working as an associate professor, Uttaranchal University, executive committee member of IEEE UP section, member of BOS committee, CRC committee, Women's Cell, ARC committee, and DRC committee of Uttaranchal University. Dr. Pooja Sapra, Associate Professor, Department of IT, Parul University, Vadodara. Her current area of research includes database security, cyber security, and blockchain technologies. She has chaired many sessions at IEEE conferences on database and network securities and is a reviewer of many Scopus Index journals. Dr. Anu Taneja, Associate Professor, BCIIT. Her primary research interests are machine learning, data sciences, social network analysis, data mining, information retrieval systems, and optimization algorithms. Ms. Nidhi Grover Raheja, currently associated with Delhi Skills and Entrepreneurship University, is in their areas data analytics department for training visualization tools and storytelling. Certified in big data and Hadoop and Spark development, she is actively and working as technical trainer in the domain of Python, advanced Python, data science, machine learning, NLP, BI tools like Tabula and Power BI. The schedule for the 5 days FDP session 1 will be between 11:30 till 1 o'clock. Session 1 taken by Dr. Anu Taneja on machine learning introduction. Session 2 followed by session 1, after session 1, machine learning fundamentals by Dr. Meenakshi Memoria. Day 2, session 3 and 4 will be taken by Ms. Nidhi Grover Raheja. Day 3, session 5 and 6 will be taken by Dr. Pooja Sapra. Session 7 and 8 on day 4 will be taken by Dr. Anu Taneja. Session 9 will be continued by Ms. Nidhi Grover Raheja, followed by a valedictory session, vote of thanks, and online quiz on day 5. There will be time for questions at the end of each session. Now, I will pass you over to my colleague, Dr. Anu Taneja, to continue with the session 1 of FDP. Thank you.
Thank you so much, ma'am. Now, I would request Dr. Anu Taneja, Associate Professor, BCIIT, to continue with the session. Over to you, Anu ma'am.
Thank you. Thank you so much, Dr. Sushma and Ms. Sonia. Thank you so much for such a warm welcome. I welcome all the participants on the first day session. So first of all, I would like to wish a very happy Teachers' Day to all the teaching fraternity. We all are here to learn about today's machine learning. So I'll start up with my session. I hope I'm audible.
Yes, ma'am, you are audible.
Okay, thank you for acknowledgement. So we will start with the session that is Introduction to Machine Learning. Just let me share the screen. We have all heard all these terms various times, but we all are confused what exactly is or how simple can we make life with our machine learning. So let's start with the session. So very warm welcome to the FTP organized by Banarsi Das Chandiwala Institute of Information Technology. The outline of the session is already discussed by Dr. Sushma. So I'll be taking the first session, that is machine learning introduction. So basically what exactly machine learning is, very vague terms are in our minds. So I'll try to simplify all the terms related to machine learning into today's session. I'll try to simplify the terms. If you're having any doubts, you can put up in your chat box. I'll take up the queries as well. So firstly, let's start where exactly machine learning fits in. So 3 terms are there which creates chaos in our mind, what exactly they are. Artificial intelligence, machine learning, and deep learning. I hope my screen is shared, right? My screen is visible to all? Okay. So let's start up with what exactly artificial intelligence is. Now, Artificial, as the name suggests, artificial means man-made, and intelligence means you want to apply your knowledge. Now, artificial intelligence means you want to mimic the human intelligence. So, are the terms related? Are artificial intelligence are similar to machine learning, or are there any some differences between both the terms? So, we need to clarify what exactly the terms are. So artificial intelligence, machine learning, and deep learning all are correlated to each other. They all are the most trending technologies, basically, which are used for creating the intelligent systems. Now, what are intelligent systems? Intelligent means who can think of their own. Who can think of their own means those can take decisions like humans can take. So we are able to think, we are able to analyze, we are able to take decisions. That is what we are expecting from machines also. So artificial intelligence is the broader term that has a wider scope, and machine learning is a subset of artificial intelligence. It is a subfield of artificial intelligence, as AI also includes computer vision, robotics, natural language processing. Similarly, machine learning is one of the subfield of artificial intelligence where we want our machines to learn from the data without being explicitly programmed. So we all have heard these terms, but I try to explain everything word by word so that terms get very much clarity in your mind what exactly machine learning is, and I can create interest in your minds that what exactly the machine learning is. So machine learning is the subfield of AI, and what exactly then deep learning is? Deep learning is the subfield of machine learning, which is basically inspired by the biological neurons, that is human brain cells in our mind, that is inspired from neurons. So artificial intelligence, machine learning, and deep learning are all trending technologies and correlated to each other, but they are subsets of artificial intelligence, and deep learning is a subset of machine learning. So in this way, we have to now mainly focus on machine learning. So let's focus on machine learning part. But before that, we should be clear what is the exactly where machine learning fits into the picture. Now we will start with, this is the major difference between machine learning and deep learning. I have also visualized. In machine learning, we have to manually extract the features. But in deep learning, there is no need to extract the features. They are actually learned from itself from the deep learning. Right? So I hope it's clear. Machine learning, we have to manually extract the features, and we have to do the classifications, we have to predict the outputs. But in deep learning, there is no need of manual feature extraction. We have to learn, a system itself learns the features and classifies the output. So I hope you are clear with the terms. What is AI? What is ML? What is deep learning? Where machine learning fits into? And what is the major difference between ML and DL? Right? Now I'll focus in my today's 1.5 session. I try to give up as maximum input as possible. What exactly machine learning is and what are the terms related to machine learning. See, what is machine learning? Very interesting question. Humans used to learn from the experience, right? If we need to train any kid, we are all having kids at our homes. Kids used to learn from its experience. He learns this is an apple, this is a cat, this is a dog. So we used to guide the human being. We used to guide the kid that this is an apple, this is a cat, this is a dog. Maybe twice or thrice he tells us wrong answers, but eventually with time he learns out with the experience. Yes, that this image is an apple, this image is a dog, this image is a cat. So human beings learn everything from experience. So now the same question is asked from machines. Can you learn from experience? So answer is yes, machines can also learn from experience, but experience is past data here. How machines can learn? Machines can learn from the past data. just hold on and continue. I hope my slides are changing.
Yes, ma'am.
Okay, okay. So we will learn now. Humans learn from experience, right? So I have given you the example very clearly that humans learn from experience. We used to learn out the kids, and eventually with time, he learns from the experience. So can machines also learn? This is the question now. If we can make machines learn, then that will be an interesting job. We can do our tedious stuff and tasks and make our machines to learn, right? So machines can learn from experience, but what does experience here means? Experience here means from the data. The more data we feed to the machine, the more good will the machine will be able to learn, and more good will be the output, more good will be the predictions, more accurate will be the results. So this is exactly the meaning of machine learning. We want to machines learn from experience, and experience means past data. So more the data we are feeding to the machine, the more they will be able to analyze the examples, the data which we are feeding, and more accurate the results we will get. So this is how what we mean exactly by machine learning, right? You can ask me, unmute yourself and ask your doubts, or you can put up in the chat box, I'll answer it, right? So let it be a two-way communication. Just hold on. Okay, we will continue. There was some problem in changing of slides, so I'll continue with the presentation. So next is, now we have learned what is machine learning, right? Now we will see. Just a second.
पीछे आना उस तरफ, आगे जाना इस तरफ, हो गया।
ठीक है। Okay, so we will continue. So we have seen what is machine learning. Now we will see. So now we can define machine learning. Arthur Samuel has given its definition, who is known as the father of ML, has very clearly defined what is machine learning. Now from this pictorial representation, we can easily define what is machine learning. So machine learning is a subset of AI that we have seen where it fits in. that is concerned with the development of algorithms. We need to build our models. We need to develop the algorithms which allow computer, first important term, that is which allows us to learn from the past data, because we want our machines to learn from experience, and experience means past data. Now we have to predict the outputs, and then we have to improve our predictions. Improve our predictions means we need to improve the accuracy. So this is the meaning. We need to learn from the data. We need to predict the output for the problems. And after predictions, we need to evaluate its accuracy. And if the results are not accurate, we need to improve our results. We need to enhance our accuracy. So these three terms clearly define what is machine learning. That enables the machine to automatically learn from the past data, predicts the results, predictions, outputs, and improve the accuracy. Now how you will evaluate, what algorithms you will apply, that we will see what algorithms are applied in every case. So this is, till now we have seen what is machine learning. Now the next question is, before machine learning also we were developing algorithms, we were doing programming, right? So what is the difference between traditional programming and machine learning? Next question that arises in our mind. In traditional programming, you are using some software stack like Java, mean stack, any stack you are using to develop your softwares. But all those softwares are developed using given some set of instructions. You are defining some set of instructions. You are defining some set of rules. You are giving the input to the program, and then you are getting the desired output. But in machine learning, you are still giving the input, because more the data that you will be feeding to the machine, more will be the accuracy. But along with the input, you are also telling that this should be the output. Now that algorithm is developed, now you are trying to develop the rules from that machine learning program. So this is output will be, you are defining some new set of rules. You are trying to analyze the hidden patterns inside the data. You are trying to analyze what new rules can be developed, how predictions can be done easily, which humans can't do. So this is the major difference between programming we were doing earlier also, but in that we were just instructing the machine, we were defining some set of instructions, and that set of instructions were acting and we were getting the outputs. But in machine learning, we are also giving the outputs and then deriving some new set of rules. What new set of rules can be learned so that we can improve our prediction results if unobserved data or if new data is coming and given as an input to our models. So this is, it's nothing new. We were programming earlier also, but this makes a difference. This comes to the role of machine learning. We want our machines to make intelligent. We want our machines to learn from the past data. So another major difference you can see from this slide very easily, that you were giving the input, you developed your software, run it on some classic CPUs, and then you are getting the outputs. Now that framework can be JavaScript, C#, mean, Java, etc. But you were having some predefined rules that were coded by humans and you were getting outputs. But now in machine learning, the work is reversed. Now you are learning from the knowledge. You are applying your algorithm on the data set. You are running your programs on GPUs and high advanced CPUs, and you are training on your data. You are providing, machine is learning from your examples, rather than you are explicitly programming everything. That these are the set of rules, just process it and gives the output. You are defining some, you are defining the input, you are defining the data, you are telling the output, and then you are predicting. So this is the major difference. You should know how we have evolved to the concept of machine learning, or what is the basic difference between traditional programming and machine learning, right? So I hope it's clear. Now the very important question is, when you will use machine learning. Can machine learning be used on every problem? No. Simple, it's not the case that machine learning is on boom or it is a trending technology. You can use it to solve every problem. That is not the case. So where you will apply machine learning, where you can apply machine learning, if it is not applicable to every problem, then where you will apply? Now this is the question. So machine learning is not a solution for every type of problem. There are certain cases where you can apply, where Robust solutions can be developed. Many problems are there. Suppose you need to calculate the salary of an employee. There is no need to apply machine learning or that. So if you are having some predefined set of rules and you are expecting outputs, then there is no need to apply machine learning. So it's not the case it is on boom or it is a trending technology. You can pick up any problem and apply machine learning algorithms. No, certainly not. This is not the case. So the question is where you will apply machine learning. So where you cannot code the rules. What now? How where you can't define all the rules. That is one of the area or situation where you can apply machine learning, where you can't code all the rules. Okay, I'll give you one basic example. Suppose you always used to check out your mails. Some mails are coming in your primary mails. Some mails are coming as a spam mail. Some mails are not spam mails. So it is filtering out the mails in the category say spam and not spam. Now, if we don't apply machine learning, you will have to define the rules. You have to define various rules to check out whether this is a spam mail or whether this is a not spam mail. So now whether a mail is spam mail or it is not a spam mail, there will be various factors that will be influencing. Whether it is a spam mail, so keywords will be checked, how many times you are checking, what is the length of the email, what attachments are there. So there are various factors that will be influencing the category to categorize it into a spam mail or not a spam mail. So you will have to define all the rules that will be dependent on various factors. And it can be the case that many of the rules are overlapping and you need to tune them finally. So if there are hundreds of mails, say I ask you to check for the 100 mails, maybe you do it manually. For 100 mails, you define them. But if there are millions of mails, it can be the case your rule database becomes small. You may have missed out some out of the things. So in such cases where rules are to be coded and they are very large and we want our machine to learn, we want our machine to learn from the data we are providing, that if certain new rule comes into picture, then you have to analyze on the basis of that whether it will be a spam mail or it will be a not spam mail. So here comes into the picture machine learning, where you can categorize email is a spam mail or email is not a spam mail. So when the rules are not fixed, rules are variable, rules are you are not able to code out all the rules. This is one of the area, one of this use case, one of the scenario where you will apply machine learning, right? Second situation can be where you can't scale out. Like I give you the example in the same, maybe manually you are able to recognize that these 100 mails will be out of these 70 will be spam and not spam based on the factors which you have figured out for categorizing it as a spam or not spam mail. But when it becomes for the millions of emails, then machine learning will be an effective solution for such large scale problems. So when you are not able to scale out the problems, when you are not able to code out all the rules, these are certain situations where you will apply machine learning. So where human expertise doesn't exist, I have given some use case scenarios here also. You are trying to explore some new territory on the Mars. You can't explain your expertise. You are working on the large amount of data. You need the scalability. You are not fixed with the rules. You can't code out all the rules. So in such cases, you will go for machine learning. For predefined problems, for predefined set, like I have given you the simple problem, you need to calculate the grade of the student, you need to calculate the salary of an employee. So it's fixed. You need to tell the system this will be the basic, this will be the DA, this will be the HRA, this is the number of days he was present, and you can simply calculate the payroll. So this is not the example of the machine learning. So I hope till now you are clear. Till now I'll summarize what I told so that I want you to be in the sync with me. Machine learning is a subfield of AI. Machine learning learns from the experience. Experience means past data. So what exactly machine learning is? That learns, that predicts, and that improves. And then we see, we were earlier also programming. So what exactly the difference between traditional programming and machine learning? And then where to apply machine learning, that is the biggest question. It's not out of the current trends you will apply machine learning to any problem. You should be certain whether this is the correct problem, whether this is the correct problem to be applied for machine learning. So next we will move further after this. What are the different application areas of machine learning where you can apply machine learning? So these are the certain industries just I have mentioned where you have heavily machine learning is being utilized in this industry. So machine learning applications in healthcare, it can be drug discovery, it can be finance, it can be retail, it can be travel industry, it can be social media, mechanical engineering, face detection and recognition. So we will see, you should know where the areas where the machine learning and for what work they are being utilized in different industries. In healthcare, so I'll explain one by one. In healthcare, how machine learning is utilized. So how machine learning is utilized? Suppose for basically for your personalized treatment, for your medication, you want some medication, uh, you need some proper treatment from the doctor. Suppose you go to the visit the doctor and you are having a stomach ache. Now what doctor will do? If you are not applying machine learning, what doctor will do? He will analyze your symptoms. He will ask you to do some tests. He will ask you to do some MRIs. He will ask you to do some CT scans. He'll study out the reports. He'll study out your previous medical history. He will study out your previous family history. And then it will try to compare it with the latest research that is going on. So after comparing your symptoms, your medical history, your family history, then he will say out, yes, this might be the problem. This might be the problem to you and give you the some treatment, advise you the treatment to take up. Now here machine learning comes into picture to make a mark in personalized care. Now what if this thing can be effectively or it can be automated? Otherwise the task is tedious. I'm telling all my records are stored. Now it can be, I have defined all the rules. Whenever I'm feeding, I'm training my machine with large set of data. Now I'm asking for the medical treatment. So here you can apply for the machine learning. That will help me out in the personalized treatment or medication or treatment, what I want for my problem. Second area is where I can use machine learning, that is drug discovery. Drug discovery means, I hope you all have heard about Pfizer. That is using machine learning technology for the years to sieve through the data to facilitate the research in drug discovery. Otherwise, you see one drug to be discovered take many years and it has to be tested. So if we can work out where the research area is still in under exploration, where we can apply machine learning, we can reduce up the time to discover the drugs. So Pfizer is already using that machine learning technology to manufacture the drug or to discover the new drugs with different salts. So this is how where machine learning comes into picture. Third major area is in finance industry. So where it works in the finance industry to detect the frauds which are going on. How you will identify if there is some user, like someone asks you to let me know you come some link on your mobile phones, ask you to provide the OTP, someone say by mistake provides the OTP. So how in fraud detections we can utilize machine learning? How we can utilize machine learning will try to find out some unusual behavior. If there is some unusual activity with your accounts or with your statements, then it means we can detect the patterns, we can detect the unusual behavior through machine learning algorithms, which will be able to minimize the frauds. So through machine learning, we can detect the frauds that is being used in the finance industry. I hope you all are knowing PayPal is already using machine learning to fight against the money laundering. So this is various industries are already that are using machine learning. Second thing, like one is the fraud. Second thing where you can use finances for checking out whether the customer is eligible for loan or not. So what banks are giving us loans and they are getting various huge amount of benefits on the interest which they are on their loans which they are getting. So but bank can't provide loans to every customer. So it has to be identified whether we should provide loan to this customer or not, because he should be eligible to pay off that amount also. So machine learning comes into picture to help out the banks whether the participant is eligible for loans or no, not. So we can easily do that. We can check out its past records. We can check out its credit score. So different mechanisms, different parameters can be given as an input to the machine learning algorithms to detect whether the participant is eligible for loan or not. So these are different use cases or scenarios or applications or situations in finance industry where we can utilize machine learning algorithms to ease our task. Next is one more example I can discuss. You can check out the stock market forecasting where machine learning is being used heavily. We need to check out what will be the stock price. You need to whether it will be going up or it will be going down. Accordingly, the shares will be purchased or not purchased. So in this way, in finance industry, it is being used heavily. Fourth application where machine learning is used, that is in the retail industry. Now what is retail industry? You all are experiencing every day. You are going on Amazon to buy some book, then that Amazon system is giving you the suggestions that who have bought this books also have preferred to buy this book. So this is what they are trying to increase the targeted customers. They are trying to increase their revenue. So this is the meaning how the retail industry is utilizing machine learning to increase their revenue, to increase the customers, to increase their market value. So one of the example is in product recommendations. I suppose I bought this Shakespeare book. Now who bought this Shakespeare book or will also be given me as the suggestions that you can buy this book also because other authors also like this book who read this book. So this is one of the use case in the retail industry. Second, in the retail industry, in some of the websites and Flipkart and Netflix, chatbot services are there. You are also experiencing in very educational website also to improve the customer service. You will feel like that you are talking to a human being, but that is acting as a chatbot. So based on your keywords, it stores the data and then on the basis of your keywords, it answers. So this is another scenario in the retail industry. Chatbots are being used to enhance the customer service, to increase the customer satisfaction. So this is the another example that can be used. Third scenario that I can think of is market basket analysis in retail industry. Market basket analysis means suppose I have purchased bread and butter. Then it may be the case that I would like to prefer to buy egg also. I would like to prefer jam also. So this is the machine learning algorithms are trying to find the correlations between the items that I have purchased. So if someone has purchased bread and butter, now system will start recommending that you can purchase egg and jam also. That will also be beneficial. So user thinks, yes, I may need this also. So they are increasing their revenue. They are increasing the customer attentions towards the different products. So this is how they are enhancing their revenue. So this is another use case scenario that we are having in the retail industry. Fourth use case scenario that I can explain, that is sales forecast. From the past data, we can forecast, we can predict what will be the sale. Suppose I give you the real scenario. I have some companies there and say I'm the owner of that. From the past data, I can see, I can check out in this month, this was the sale, and this month, this was the sale. Now, what will be the sale in the end of the December? I can predict that sales on the basis of past data. So here I'm not concerned about what machine learning algorithms you will be applying, but here I'm making you comfortable where machine learning is being utilized and what should be the nature of the problem where you can apply machine learning. Because as we have already seen, it's not the case that every problem can be solved using machine learning. You should be clear with the nature of the problem and how it can be applied in different industries. What are different use cases where this machine learning is being, how it is being utilized in different industries. So I have discussed above four, that is healthcare, drug discovery, in finance industry, how it is being utilized, in retail industry, how it is being utilized. So we should know the use cases in the real life, how it is being applied. Next, fifth application, fifth industry, that is the most prominent industry, that is the travel industry, which was on downfall due to COVID, right? But how machine learning is being utilized? Uh, Machine learning, if I give you the real example, you might have gone through the website TripAdvisor that uses sentiment analysis algorithms to enhance its service, because TripAdvisor get millions of reviews on their website regarding the travelings. So what they do now, on the basis of that, they try to analyze the reviews, divide them onto the scale, whether the reviews were positive, whether the reviews were neutral, whether the reviews were negative. Now, how negative reviewers can be converted into positive reviewers, or how positive reviewers can be remain consistent, what offers, what discounts we can give to them. So this is one of the area we are trying to catch the attentions of the users. We are trying to attract the customers. We are providing a TripAdvisor or any XYZ website is trying to provide offers to their customers. They are giving some vouchers, they are giving some discount plans, they are giving various offers to their customers, so that the customers who are already as a positive reviewer, they remain consistent throughout. And those are negative reviewers, how they can be turned into positive, how neutral can be turned into positive. So these are the machine learning algorithms. They are doing sentiment analysis, they are applying machine learning algorithms to get the reviews of different users, and can enhance the customer service and can increase their business, can leverage out their business to the next level. So this is how the machine learning is again being utilized in the travel industry. Suppose you another use case scenario can be, suppose you try to you are planning to visit to this some country, and you try to check out what places, or you are trying to fix out your itinerary, then what places you will visit. They will recommend you that these are the most popular places you should visit. According to your interest, they will recommend you. It's not the case that they will travel you randomly. Either most trending places will be suggested, or most popular places will be suggested, or it can be according to different features of your data that you have provided. It can be the case that you have given us an input that you have submitted your age group, you have submitted that you are male or female. Now according to your interest, only suggestions will be suggested. So this is how machine learning is being again utilized. First of all, before that, we used to call up the person living at that place. Can you suggest me what will be the places? But now we don't need to call up any that person. He may or may not live at that place. So now the system automatically suggests us the places to visit, what food in fact we can have there, what other activities we can plan out there. All those activities along with the travel destinations are recommended to us, are suggested to us. So this is how machine learning is being utilized in the travel industry. So I'm discussing different use case scenarios you can which you can easily identify in your daily lives also, that we are using that machine learning in this travel industry. So I hope I'm clear till here to everyone. Is it okay to all? Right. So next one is social media. How social media is utilizing the machine learning. I give you the very basic example on Facebook's. What you used to see, whenever you tag some person, auto tagging suggestions are given to you that you might tag this person also. You might tag this person also. In fact, along with the names, they are giving you the suggestions. So this is how in social media we can utilize the machine learning, right? Another, LinkedIn. You have created your profile on LinkedIn. Now jobs are recommended according to the data which you have feed on. You have feed your skills, you have feed your experience, you have feed your past working, past employment history. Based on that skills, based on that keywords which you have given as an input, LinkedIn is suggesting you to the jobs. LinkedIn is suggesting you the programs also that you can do for your betterment. So this is how LinkedIn, how Twitter, how Facebook is utilizing machine learning. Next application area is not, it's not confined only to computer science, or it's not only confined to e-commerce industries or healthcare industry. In mechanical engineering also it is being heavily utilized. How in mechanical engineering? For objects detection. For object detection, I want to distinguish out the objects. I want to distinguish different objects. Like I want to distinguish whether it is a seabird or whether it is some aquatic organism. So object detection, in object detection, machine learning is being used heavily, right? Next one is, I have listed some applications here. Many of the applications are there. Last one is in face detection or face recognition. In Facebook, like I have given you the example, tagging suggestions are given to you. In fact, Facebook is running its deep face project behind us to give you the automatic tag suggestions, to let you know that these users you can tag out for this newsfeed, for this post. So this is one of the examples. Second, you are using in your mobile phones, you are using in your laptops, you are using as biometrics to check out how face detection is working. That is scanning out your image, that is scanning out your face, that is consisting of different pixels, different features, and machine learning algorithms are used at backend to detect whether this is the correct user or not. For security purpose, for biometrics, for Facebook, we are already using. So these are different use case scenarios in this industry where machine learning is being used heavily. So I hope you are clear with, you are not only clear with where the industries where they are being used, you are clear with the use case scenarios, what are the different application areas in different industry where machine learning is being used heavily. Now we will switch to the, I have given, which you have heard various times, that was, I have divided it into now, not industry wise, which you are using nowadays very heavily. Speech and image recognition. You are using Alexa, you are using Siri, you are using Cortana, you are using various things in your life. You are using Google Assistant, you are just speaking out, and speech to text, face unlock, you are just asking, you are asking Siri to let me know the today's date, you are asking Siri to someone. So what it is doing? Recognizing your image, applying natural language processing, applying machine learning algorithms, converting speech into text, and giving you the outputs, giving you the desired outputs, what you are expecting from the assistant. Image recognition, same as we discussed, we can use it in biometrics, we can use in security, we can use it in Facebook, we are seeing. So this is one of the application area where speech and image recognition is being used heavily. Second application that you see, that is traffic alerts using Google Map. Anywhere you want to visit, first of all, you switch on your Google Map and check out whether I should prefer to move towards this route or not. So traffic alert, what it is using behind, using machine learning algorithms. This is not the preferred route, this will take this much time, this will take this much time. So machine learning algorithms are being used to alert you for the traffic, which you can easily view on the Google Maps. Third one, as we have discussed these use case scenarios, chatbots. What different educational websites, different retail industries, different e-commerce industries are using chatbots to increase the customer satisfaction, to enhance their service, to give quick reply to the customers, because customers are get panic when they are not getting quick replies to the queries which they are submitting. They need quick replies within a span of seconds. So chatbots are recognizing your keywords and giving you the desired outputs. Next use case scenarios is Google Translation. You are using Google Translation. Google Translation means basically Google Translation, if you are aware, Google is using neural machine translation that will detect your text, that will translate it into the language, into the desired language, into your native language, and will give you the desired output. So this is how machine learning is being used. Predictions, we can see we have to predict whether the customer is eligible for loan or not, whether this customer will do a credit fraud or not, whether this customer, we need to predict the preferences of the customers in the e-commerce industry, we need to predict whether the user will buy that movie or not, we need to predict whether the user will watch that movie, will buy that book. These all are the predictions that we are going to do. We are telling the users the probability whether they will do this thing or not. So this is called where machine learning is being utilized heavily for predictions. Next one is extraction. Now what does extraction means? Extraction means you are trying to extract the desired information. You are trying to diagnose something. You are trying to, from the desired information, you are trying to check whether the user is suffering from cancer or not, whether the user is suffering from diabetes or not. So what you are doing, you are restoring the images, you are storing the CT scans of the users, and then you are extracting from that structured information, you are trying to extract the outputs. So that is one of the another application area where machine learning is being used. Next one is statistical arbitrage. What is arbitrage? I hope you are aware of the term. That is basically a automatic trading process, you can say, that is used in finance industry to manage the security. So here now we are detecting whether it is a fraudulent transaction, whether it is not a fraudulent transaction. So we are using machine learning algorithms again because we don't want to give our credit cards or loans to the defaulters. We want our amount should be given back to us. So this is how we can utilize machine learning. Auto friend tagging suggestion, I already told you, Facebook is utilizing deep face project for auto tagging or giving you the suggestions that you can tag this, this as your friend, right? Self-driving cars, I hope it is already implemented. You have heard of Tesla. They are already implemented in US. There is no need of drivers. Cars are autonomous cars. They are driving with driverless. Now, how they are doing? They are using the past information. That is example of reinforcement machine learning. They are acting under certain environment and then learning from the past data and then proceeding towards the correct route. So this is again the application of the machine learning. Next is ads recommendation. Very important. Whenever you watch any video, whenever you watch something on Facebook, whenever you watch YouTube, ads are recommended to you. And it's not the case that ads are same for every user. In fact, I'm watching at the same place. Another user is also watching the same video. It's not the case both users will be getting the same ads. Ads are also recommended as per your history. So it's not the case, it can be the case that ads are also beneficial to you. Suppose I'm watching some machine learning course. Now in that I'll get some ads according to the machine learning courses only that I can enroll on, because at the ad time also they want we can convert our customer to a targeted customer. So ads also are recommended as per your interest. That is one of the example. Next application area is video surveillance. Now, what is video surveillance? We want to detect any crime before it takes place. So it's not the case कि crime हो जाएगा, then we will see to that. No, we will see, we want to detect the crime before it takes place. So how you will detect? You will try to detect some unusual activity is taking, some unusual behavior is taking, the places which are under the camera. So that can help you out. That how you will help out. There is some sort of suspicion at that place. So here you can take some precautions at that area. You will be more vigilant towards that area. So this is how machine learning algorithms are being utilized for video surveillance. Next, we have already seen email filtering. We are getting emails categorized into these are primary mails, these are promotion mails, these are spam mails, these are not spam mails. So, and many of the times, at times, in fact, they are correct. We are getting promotion mails in the promotion category only. We are getting spam mails in spam category only. We are getting not spam into not spam only. Sometimes it might be the case that I'm getting important mail in the spam category. So that is where our machine learning model is giving us inaccurate results. So there is not always we can expect 100% accuracy from the model which we have built. But yes, at times we are getting the good results. So that is one of the again example of machine learning in email filtering that is being used. Next application area is real-time dynamic pricing. I hope you are with the name you might be clear. It will be clicking your minds that you are using Uber or Ola to book up your destinations. You book up your cabs to reach some destinations. So what you observe when it is peak hours, prices are on the increase, that are called surge prices. Prices are on the hike. So according to the demand, what they are doing, they are utilizing machine learning algorithms. Traffic, what is the situation of the traffic? Are they peak hours or not? So they are demanding high prices, and that activity is conducted smoothly so they don't lose the customer also and they satisfy the customer also. So this is one of the example, real-time dynamic pricing, where machine learning algorithms are being used at backend. Gaming and education, you have already seen in gaming industries, you are having chessboard, you are playing different games with the system, and system is making moves according to their intelligence. So that is one of the sector or industry area where machine learning is being used. In education, I hope you have heard Duolingo is one of the learning app that just acts in a very interactive way, that checks out how the human being can memorize the words in a short span of time. So machine learning algorithms are being used for such gamings and to make the education as a fun. Virtual assistants, we have already seen, they are understanding our voice commands to make the task faster. Alexa, Siri, Google Assistant, Cortana, these are the different examples of virtual assistants. So now you are clear with what exactly the areas where machine learning is being utilized heavily, what are the different industries, what are the different use cases, and we are experiencing all these situations. You are experiencing everyday Google Map, you are experiencing Google Assistant, you are using it every day. You are getting ads recommendation every day. You are using Google Translator every day. You are getting auto tagging friend suggestion every day. So these are the few applications that where machine learning is being utilized heavily. So this is one part, that what exactly machine learning is, how it is different from the traditional programming, when to use machine learning, and what are the different applications of machine learning. I hope I'm clear till here to everyone. Is it okay to everyone? Can someone acknowledge me quick? Is it okay to everyone? Can we proceed? Okay. Okay. So next is how it is being used by different companies. Now, it's not the case every industry is using. If I see Google, Google is using in Google Translation, Google is using in Google Photos, Google Photos. I hope you have seen Google Photos are using, they are grouping your photos. These are selfies. These are some travel destination photos. So they are recognizing your images and classifying them into different categories. Google is using Google Assistant. You are just giving the voice command. They're converting their voice command into text and giving you the outputs. So Google Photos is using, Google Translator is using, Google Search is using. So different machine learning for different activities, these companies are using machine learning. Facebook, we have already seen. Advertisements are suggested to you on Facebook. Facebook is using chatbot, face recognition, auto tagging suggestions are given to you. So this is how I want to just make you clear or visualize how different companies are using machine learning. Next is Twitter to organize the tweets. How they are organizing the tweets? They are using natural language processing on the basis of how much you are retweeting, on the basis of sentiment analysis of the tweets. They are checking out whether they are positive tweets, whether they are abusive tweets, we have to delete them. So they are using natural language processing, sentiment analysis algorithms to structure out their tweets. So this is how Twitter is also using. Pinterest, I hope you have heard about this. They are recommending the interest based on the penning history. What you are penning, on the basis of that, they are giving you the suggestions. Amazon, we have seen you are buying different products. They are suggesting you according to the that product. Suppose I bought some iPhone from the Amazon, then it will suggest me that you can buy this accessory also along with this iPhone. You can buy, otherwise you can buy this upgraded model. So as per my history, as per my browsing history, as per my area of interest, they are giving me the suggestions. So this is how machine learning is being used by different companies, how machine learning is used in different industries, and how machine learning is being used in different use cases in different industries. So this was the one introduction to the machine learning that you should be clear with, that it's not new to us. We are already using it day by day in our daily lives, and we are heavily used to this. But yes, we should know now how the working is, how it is working at backend. What are the rules behind that? What algorithm is being used? So that we will discuss in the upcoming sessions, right? So this is basically the workflow, or you can say how machine learning works. What is the process, how it works basically. So there are different terms that are being introduced in the machine learning. First term is the training data. Training data means that the data which you are giving to your machine, on which your machine is being trained. You are providing a huge set of data to your machine. That will be considered as a training data. That are different set of examples that you are giving. Suppose I make you very clear with the terms, what is training, what is testing, what is accuracy. Suppose I have given 5 maths questions to a kid. I have given these 5 questions to a kid. I make him understand. I explain all the questions. I explain all the solutions. Now kid is comfortable that suppose I'm giving to do addition of these questions. Now kid is comfortable to do addition problem in mathematics. He has learned from different examples, 5 examples which I have given. That is called the data which I have given. Now suppose I need to check the intelligence of the kid, whether he has certainly learned or not. Same is the case with machine. I'm giving data to the machine. I have trained that machine. I have trained the kid for the addition problem. Now I'm evaluating the kid's knowledge. Means now I'm giving again 3 questions to the kid based on the addition problems only, which I have already explained to you. That 3 addition problems will be different. So that will be acting as a test data for the kid. So now I will evaluate whether kid is performing these 3 questions perfectly or not. If it is perfecting, now what I'm trying to do? I'm trying to evaluate the model which I have built on different set of observations. I'm giving different input. I have given 3 different questions to the kid to solve. So that is acting as a test data on which I will be evaluating or predicting the accuracy of the model. If the kid has solved all the 3 questions, it means 10 on 10 marks for every question I have given. Kid has learned addition problem very well. But it can be the case kid has done 1 question wrong. So it means 2 questions are correct. So 20 out of 30 marks he has scored. Same as the flow with machine learning also. I'm providing the data that is called the training data. I generally divide my data into 2 parts. One is training data and one is test data. Training data is on which I'm training the machine. Like 5 questions given to the kid that were acting as a training data. Now I have given 3 questions that were different problems. So that is testing data. So 8 is the total number of problems. Out of that, 5 will be acting as a training data and 3 will be acting as a test data on which I will be predicting the accuracy of the model. So I am having the training data. I'm building some machine learning algorithm. I'm modeling that input against that training algorithm, applying machine learning algorithm, giving this new observations that is test data as an input to the model which I have built. Now that model will do the predictions and will let me know the accuracy. If it is okay, then model was successful. And if it was not okay, it was below the threshold, then that means I need to retrain my model. How now I can retrain? It can be the case I need to give more data to the user. Means suppose user has not done any question correct. He has scored 0 question out of 3. So it means I need to make the kid understand again more problems. I need to give more examples of addition problems. So it means I need to train the kid again for addition problem. Same is the case with machine. If accuracy is not up to the mark, that is unacceptable. I need to retrain that machine. I need to retrain. Again, I will model. Again, I will provide new set of data. And again, I'll predict. Again, I'll evaluate the accuracy. So this is how machine learning works. You divide your data into 2 parts. That is your training data. That is your testing data. I hope now you are clear. We are having a data. We are having a set of data. We divide it into 2 parts, training data, on which we will build our model. And now if we have to evaluate the accuracy, then we will use the test data. That will be helpful for us to evaluate the accuracy of the model. If it is not accurate, not giving the up to the mark results, it means we need to retrain. Now, how we need to retrain? That means we need to, maybe we want to give more data so that machine can learn. As more data will be fed to the machine, more accurate results will be given to us. Because if I'm explaining the kid hundreds of addition problems, then chances of accuracy are more. He will be more comfortable in doing the addition problems. Same is the case with machine. So it's nothing new. Just you have to explore out your minds. You have to check out the mathematics behind the algorithms, and the flow will remain the same. Flow will remain uniform throughout the machine learning algorithm. So it's not like that. It's just the combination of computer science and statistics that you have to apply the algorithms and predict out the results and evaluate your accuracy. So this is the flow of the machine learning. So it's as easy field as that. Right? So this is how we are trying to extracting the patterns from the data. We are trying to train the machine, and then we are trying to predict the results. That is, we are trying to evaluate the accuracy. Now different metrics are there how you will evaluate the accuracy. Now for a kid, I'm checking it manually and then saying that accuracy is perfect. Now how you will evaluate the machine, that is again a different question. Which machine learning algorithm you will apply for this problem, this is again a question. So this is what we have to think of. Now we are clear that for this problem we have to apply machine learning. Which algorithm to be applied to build your model, this is your first question. Which accuracy metric you will be applying to evaluate the accuracy of your model, this is your next question. So these are the questions, these are the black box questions that you will be getting out in your upcoming sessions, how algorithms are applied and how you will be evaluating the accuracy. In fact, we will be doing hands-on exercises, not only conceptual part, we will be doing how to build the models, right? But first, the concept should be clear in your minds. Yes, exactly, this is machine learning. It should, my target is to make the subject more interesting to you so that you can, whenever you read, you gain out the interest. Yes, machine learning is an interesting subject, right? So this is, I have explained the flow. You have to identify what data you are going to work. So you have to identify what data you are going to work, how you will gather that data, how you will find that data, whether it will be a real data or it will be found in some repository. So you have to find on which data you are going to work, in which domain you are going to work. So that is your first step. And then you have to prepare it for analysis. Prepare it means you have to pre-process your data, because it can be the case data is not in a form that can be used directly. So you need to pre-process your data. So this is the first step of any machine learning. Whatever machine learning algorithm you apply, you first need to understand the problem. You need to understand the nature of the problem. You need to identify on which data you will be working and whether that data is, you can use it directly, or you need to apply some pre-processing steps to make it use to give it as an input to your machine learning model. After that, you will apply, depending on how the data is, what you have to do in that. Accordingly, you will decide which machine learning algorithm you have to apply. Now you have decided this is my data. This data has these features. Depending on the data, you will have to decide on this data, this machine learning algorithm will be applicable. After that, you will build the model based on the algorithm. After that, as I discussed, you will train the model. And after training the model on that training data, you will give as an input test data to evaluate the score or to evaluate the accuracy and what other conclusions you are getting from the model which you have built. So this is the machine learning process. First step is data collection, data pre-processing, machine learning algorithm, building of a model, training and testing, and then on evaluating the accuracy on the test data. So now I hope you are clear the words which make you confused generally. What is training data? What is testing data? On accuracy is evaluated on which type of data? So which machine learning algorithm has to be applied? How we will check that? So these are the steps, because everyone applies some machine learning algorithm, get very good, beautiful graphs, colorful graphs, but they are not aware what that graph is showing, what that graph is conveying, how it is doing, why they have applied this algorithm. or why this is a better algorithm, why they have not applied any other algorithm. So these all are the questions that should be clear in your mind. If you are using XYZ algorithm for this data, then you should be very much convinced, yes, this is the most suitable algorithm. You should know why this is the most suitable algorithm. You are using some accuracy metric to evaluate the accuracy of your model, then you should be very much clear why you have used this accuracy metric. This is what we have to learn in the machine learning. Otherwise, everyone can plot good graphs. So many resources are available, but no one is clear behind the scene story. What exactly we are doing, what that graph is conveying, how that can be improved, that we have to learn, that we have to explore. And that is my main motive for these machine learning sessions in this online FTP. So I hope you are clear till here. What exactly you have to think of. Roadmap should be clear before diving into the details of the algorithm, right? This is the, I have now portrayed it in the form of cycle, which I have explained. This is first step, you need to gather the data. Second step is gather the data means how you will gather the data, how you will collect the data, whether that data will be available, whether that data is available online on some online repository, or it is a government sector data, or you are crawling it from some website. So how you are gathering the data. Second step is after you have collected your data, second step is data preparation. Data preparation means you need to pre-process your data because it is not in the direct form of usage. It can be or it cannot be. The second step is data preparation. That means you need to explore your data. That means how you will explore data, you will need to understand the nature of the data that you have to work with. What are the characteristics of the data? What is the format of the data? What is the quality of the data? If you are finding some general trend between the data. So this is called data preparation. You are trying to find the format, you are trying to find what are the features, what are the different attributes in this data set. That is, you are trying to explore your data more. Third step is data wrangling. Data wrangling means process of converting the raw data into the cleaned form, into the usable format. That is, you are trying to now pre-process your data into the usable format. You are trying to find whether some values are missing in some attribute, any missing values are there, any invalid data is there, then you have to clean your data. That is the part of the data wrangling. Then you have to analyze the data. Analysis means now you will check out which machine learning algorithm is most suitable for this type of problem, for this type of data. Then after you have done this first, second, third, fourth step, means you are done with the data part. You have cleaned your data part, that is ready for use now. And accordingly, you have decided the machine learning algorithm. Now you will train that model. Training means understanding various patterns, understanding different rules inside that data. And then you will test the model. So the example which I have given you of addition problem that are given to kids, I hope that made you very much clear. 8 problems, 5-word training, which I have explained one by one, 3-word part of the testing, on the basis of which I'm evaluating the accuracy of the kit. Same is the case with the machine. Say I'm giving 10 instances to the machine, 80% I have put into the training data, because more will be the training data, more better the machine will learn. The more will the machine learn, the more accurate will be the results. So now I'll give 2 new observations as an input to the as a test data, and the machine will be, accuracy of the model will be evaluated. So once you have applied machine learning algorithm, you have trained the model on the training data, you have evaluated the accuracy on the test data. Now you are ready to deploy your model on the real terms. Now you are ready to deploy your model in the real system, because we are building machine learning system to have to use it in the real life. We are trying to build some real life applications. So this will be the entire flow. You should be clear what steps you have to follow while you are building, while you are implementing any machine learning algorithm for building any real application. So I hope you are clear with what is machine learning, its life cycle, where to use, what are different application areas. I hope I'm clear. I have simplified all the terms. Is it okay to all? Next is, now what do you mean by learning actually? We say machine learning. What we mean by learning? Data is so much. We want to convert our experience into knowledge. We want to convert, learning means we want to convert our expertise into knowledge now. So that knowledge that we need to learn, how we will gain that knowledge, how machine will that gain knowledge, how machine will become intelligent, how machine will help us to predict out the results. That is what we make them want to make the machine to learn. That is, we want to give good approximations to our data, what better predictions we can do. This is what we mean by learning in machine learning. Why I have talked learning now? Because depending on how you are learning, how you are making the machine to learn, will divide the machine learning into different categories. That is, now divided into different types of learning, that is supervised learning, unsupervised learning, reinforcement learning. So depending on how you are making the machine to learn, how you can keep an example of kid in your minds, how you are making the kid to learn or how you are making the machine to learn, have categorized it into three different types. That is supervised learning, unsupervised learning, and reinforcement learning. Supervised means now kid is learning under my supervision, under teacher supervision. That is called supervised learning. Same is the case with machine also. Supervised learning means machine is learning under supervision. Under supervision means now machine is learning under supervision doesn't mean some instructor is there to supervise. No. In machine learning, supervised means supervision means labeled data is there. That is the meaning of supervised learning. Now, what does labeled data means? I hope everyone is with me till now. Can someone acknowledge if I need to repeat anything or I need to tell anything? Is it okay to all? Okay, thank you for the acknowledgement. So depending on the different types of learning, now I tell machine is learning under supervision. Under supervision means not the instructor in the case of machines. That is the labeled data. Now you should know the meaning what is labeled data. Labeled data means you are providing data to the machine, okay, on the basis of which machine will be trained. That is also okay. Now what that data consists of? I'm saying that data is labeled. Labeled means corresponding to inputs, you are having predefined outputs for that inputs. Like, say I'm feeding to the machine, I'll show with an example. This is the input I'm giving to the machine and I'm feeding this as a data to the machine. So I'm telling to the machine that this is an apple. So that is called labeled data. This is my training data, which I'm giving to the machine on the basis of which machine will learn. But what does this mean? This means I'm providing supervised machine learning algorithm. Now supervised means machine is learning under supervision. Under supervision means we are providing labeled data. Labeled data means corresponding to input, we are telling the output. That is, we are telling whatever input we are giving. This is, we are providing apple image. So we are telling, yes, these are apples. Now this is the test data I'm giving to the model, that this is, I'm giving some image. Now machine has to predict on the basis of what it has learned. So if it predicts accurately, yes, it's an apple, it's predicting, it means my model has learned well. My accuracy of the results will be better. It will be good. So this is called supervised machine learning. You are working under supervision. Under supervision means you are providing labeled data, and labeled data means corresponding to inputs, you are providing the output as well. And accordingly, when you are providing new set of observations, means you are providing test data. Now model will check whether this is, what image is this. If it is predicting an apple, it means it is a correct result. So this is the meaning of supervised learning. We need not to cram out the bookish thing that machine which learns under supervision, but we are not aware what is supervision means. So supervision means labeled data. Labeled data means our data set is consisting of input as well as output. And now we are providing the test data. So that will now model if predict correct means machine has learned well, machine has been trained well, and accordingly we will evaluate the accuracy. So this is the example of supervised learning, right? This is the meaning of supervised learning. Second type of learning algorithms are unsupervised. Unsupervised means no supervision is there. No supervision means if I'm talking about kit, I try to simulate, always try to machine learning algorithms as simplified as possible. So try to relate it with the real life. And kid is doing some problems without supervision. Without supervision means for the kid, no teacher is there. Means he's trying to practice out with the help of some tutorials, with the help of some books. He's doing that practice on of his own. No one is there to guide that kid. That is the meaning of unsupervised. Same is the case with the machine also. Machine is being trained without supervision. Now, without supervision for machine will means data is not labeled. As simple as that. Data is not labeled means we are not providing the output corresponding to the inputs. Means now machine has to find out the, has to analyze, has to figure out the hidden patterns on its own. I'm not telling this is an apple I'm providing you. Now machine has to learn based on the features of the image. Whatever data you are giving, that can be in the form of anything. So I'll show you an example. This is an unsupervised machine learning example. I'm giving this data as an input to learn. I'm giving this as a training data. You can see I have some apples, I have some different fruit, I have some 3 different types of fruits that I'm giving as an input. But now I'm not providing this is an apple, this is a mango, this is peer. I'm not providing that. It means machine is being learning itself on its own without any supervision. Means data is not labeled. Data is not labeled means I'm not providing outputs to this corresponding inputs. Now model will analyze the hidden pattern and then divide them into different categories. That these are apples based on the features. It is round, it is round in shape, it is this much of diameter, so it is called an apple. It is called a mango, it is called a pear. So this is the example of unsupervised machine learning. The kid is learning on its own with its tutorials, with some videos. Same as the case with machine. I'm providing not the label data, I'm not providing outputs to the corresponding inputs. I'm just providing the input on the basis of the patterns of the data. Machine is classifying them into grouping them into different categories. So that is called unsupervised machine learning, right? This is the second type of machine learning. Third one is reinforcement learning. So this is what I have written here also. No labels are there. No feedback I'm providing. No feedback is there. You are proceeding right in the right direction or the wrong direction. It is learning on its own. It is finding the hidden patterns on its own. So this is called unsupervised learning, right? Third type is reinforcement learning. Now, what is reinforcement learning? It is entirely different from supervised or unsupervised. That works on the basis of actions, what actions you are performing, and on the basis of that actions, you are getting rewards. I'll explain with a simple example what is reinforcement learning. Say I take the game playing is a good example of reinforcement machine learning. Say chess, I'm playing chess with this system. So chessboard is the environment and this is the agent. So system is the agent that is performing some action. Action means you are taking out some moves. You are moving, say horse 2.5 steps. You are moving some other according to the rules of the chess. So environment is the chessboard and agent is the system that is performing some action that is moving up. And accordingly, if you are moving correctly, reward will be given to you, means some positive points will be given to you. And that means you are changing the state. You are moving from the one state to another state. And if you have taken a wrong move, so some negative points will be given to you. So this is called reinforcement learning. Another use case scenario of robots used to learn from their movements eventually, whether they are navigating their arms correctly or not, whether they are navigating, whether they are moving up, whether they are moving down correctly or not. So this is called when you are learning you are performing the actions. If it is correct, you are rewarded something, and if it is not correct, you are not rewarded something. So this is called reinforcement learning. So based on the learning means you are trying to convert your expertise into knowledge. Now how that you are converting, whether it is under supervision, whether it is under without supervision, or it is on the basis of action and reward process. So accordingly, the machine learning algorithms has been divided into three categories, that is supervised, unsupervised, and reinforcement learning. And in context of machine learning, supervised and unsupervised does not mean any instructor is there. Rather, it is the meaning in the form of data is labeled or not. And what the labeling of the data means, that whether the outputs are being provided to the corresponding inputs or not. So accordingly, the machine learning algorithms have been divided into different types. So I hope I'm clear with all the three types. You should be clear so that you should know whenever you are trying to solve any problem, you should be able to categorize whether it is a supervised machine learning, whether it is unsupervised machine learning problem, or it is a reinforcement machine learning problem. So you should able to know, you should be able to, how you will come to know from the nature of the data. If in the data you are having inputs as well as outputs, means you will be applying some supervised machine learning algorithm. If outputs are not there, you are just having inputs and correspondingly you have to predict, then it means you will apply some unsupervised machine learning algorithms. If you have to eventually learn with time, you have to perform some actions from your experience and then you will learn, then this is an example of reinforcement, like self-driving cars, game playing. These all are the examples of reinforcement. So I hope you are clear with, you should be clear what are the meanings of different types of machine learning and how you will decide whether my problem is under this category or this category, because all are doing research. So you have to be very much clear. Yes, this is supervised. This is clear that we have to apply supervised machine learning algorithm. Now the next question is, which supervised machine learning algorithm has to be applied? Because multiple algorithms in supervised machine learning are there. Multiple algorithms in unsupervised machine learning are there. So how you will identify that this is the most apt algorithm, most suitable algorithm that you can apply on your research problem? This is the next question. So base should be clear. Then you can easily identify what the nature of problem is, what you are trying to solve. Is it okay till here? I hope this will narrow down your problems, whatever research problems you are working on out, that will clear now you out whether your problem is under supervised, unsupervised, or reinforcement. Now we will see in supervised what are different algorithms and what algorithm has to be applied. So that makes your research problem easy to work on, right? I have just generalized the machine learning different types. First one is supervised, second one is unsupervised, and third one is reinforcement. So now supervised learning algorithm consists of basically two types of problems that can be solved. One is regression and second one is classification. In unsupervised, two types of problems are generally solved: clustering, dimensional reduction, and association problems. So this is under the category of unsupervised. Reinforcement learning, as I've already given you the example, you have to take out the sum decisions, game playing, robot navigation, where you eventually learn with time. So we have seen, now we have to make clear whether it is a machine learning problem or not, because we have seen in the starting of the session, every problem is not solved using machine learning. So first you have to check out this. If yes, it is a machine learning problem, yes, it can give more better results if you apply machine learning algorithm, then you have to categorize whether this problem is of type supervised learning or unsupervised learning or reinforcement learning. Now you are clear. Supervised means, okay, it depends on the data. Data means labeled data should be there. Labeled data means input and outputs both are there. Unsupervised, inputs are there, but outputs are not there because data is not labeled. And reinforcement learning means you need to eventually learn with the environment, right? You need to eventually learn out with the time. So now it is clear, yes, it is a machine learning problem. Now you are clear, yes, my problem, my research problem is in the domain of supervised or unsupervised or reinforcement. Now again, you are stuck. In supervised learning, we are having different machine learning algorithms. So which algorithm you will apply? In unsupervised also, we are having different machine learning algorithms. Now which machine learning algorithm you will apply? And in reinforcement, the problems are clear that these problems can be solved using reinforcement. So now the next question we have to check out, in supervised, which algorithm will have to be applied, will be applicable on our research problem, that we have to check out. So different algorithms that are there are regression and classification, that are under the category of supervised machine learning. Now, what is regression and what is classification? It is very much clear that both are under the category of supervised machine learning. Now, as I say supervised machine learning, it should be clear in your minds, labeled data is there. Labeled data means input and outputs both are present inside the data. Now, when you will apply, when you will solve the problem using regression, and whether it will be solved using classification algorithms. So when you will apply regression, when you will have to apply some, when you have to predict some numeric value, when you have to predict some continuous value, then you will apply regression, right? Example, I need to predict what will be the temperature tomorrow on the basis of different factors which I am having in my data. What is the humidity? What is the pressure? Different factors can be there inside my data. But my research problem is to predict the temperature. That is the numeric value. That is the continuous value. And in the data set, I'm already giving ki on this date, on this day, in this city, this was the atmospheric pressure, this was the humidity level, and this was the temperature. So I'm already giving the output with the inputs. So that is, now we need to, I'm having labeled data. Input and outputs both are there. So regression algorithms, I am reached to the point that I'll apply supervised. Now whether I'll go for regression or classification, that will depend. If you want to predict some continuous value, then you will go for regression algorithms, right? And second is classification. Classification is again the part of supervised machine learning. That means data is labeled. That means input and output both are there inside your data. So I'm already providing in my data, this is the day Wednesday, this is the day 10th of September, this was the humidity level, this was the pressure, and various different factors that I'm giving as an input. But my task is not to predict the numeric value. My task is to predict whether it will be hot or cold tomorrow. I am to predict the different classic. I have to categorize the new input into different categories. That is whether it will be hot or whether it will be cold. So that is called classification problem. I hope you are clear with these algorithms make chaos in the minds of the researchers, what we have to apply. So this is how you will identify your research problem. It is supervised or not. I hope I have made clear. Now you will apply regression. If you have to predict some continuous value, you will go for regression. And if you have to categorize your data into some category and the data is labeled, obviously then you will go for classification. So I have given a very simple example to explain you. I need to predict the temperature, that is a numeric value. So that is, I will go for regression. If I have to predict, I have to classify into the categories, that is hot or cold, that are already defined in my data. And for the new data, that is the test data that I'm giving as an input to the model. So it will predict on the basis of that which the machine has learned, whether it will be hot or it will be cold. So these are the problems that can be solved under supervised machine learning. I hope now you are clear when we have to go for regression algorithms and when we have to go for classification algorithms, right? Is it okay to all? Right? Is it okay to all? So this is how I've shown one more example also. Classification, part of supervised, data is labeled, input and outputs are there. I'm having a mail. Classification means I have to divide my data into categories, whether a mail is spam mail or not a spam mail. So that is the classification problem. When I have to predict some continuous value, where it best fits this line, that is called regression problem. So this is called, you will apply, you will, for such type of data, for such type of research problem, you will go for regression algorithms. And for such type of problems where you have to categorize your data into different categories, that are called classification problems. right? So this is what I have shown in the previous slide also. Is it okay to all? Here you can see classification algorithms. I need to identify user will do fraud or not, yes or no. So that is category. I want to check out on Amazon whether the customer will retain or not, whether the customer will purchase this product or not. That is, I'm giving you the use case scenarios where classification algorithms can be applied. So whether the customer will purchase the product or not in future, yes or no, that is again the classification problem. I need to classify the image, whether it is a dog, whether it is a cat, whether it is any other animal. So I have to give the output in the form of different categories. So that is again the classification problem. I need to diagnose the problem, medical problem. I need to check whether the user is suffering from COVID or not. Yes or no, COVID positive, COVID negative. So that means what? I need to categorize my input into different categories where categories, please mark my words, where categories are already defined. That is what we mean by labeled data. We are already defined COVID positive and COVID negative in the data. So such type of problems are known as classification problems. Such type of problems will be solved using classification algorithms, right? And if I need to go predict some numeric value, then I'll go for regression. What I need to predict? I need to predict what will be the population after 5 years. I'm trying to predict some continuous value. I need to estimate the life of the person, whether what will be the life expectancy, whether he will be alive for 70 years or 80 years or 90 years. So I'm trying to predict some numeric value. I'm trying to predict the sales. I'm trying to forecast the sales. The sales that tomorrow the sales will be $200, $500. I'm trying to predict some numeric value. I want to predict the weather forecast. What will be the weather tomorrow? Whether it will be 27-degree, whether it will be 34-degree, what will be that? I need to advertise the popularity prediction. I need to predict whether my advertisements are having some impact on the sales or not. So what will be the sale? So wherever I need to predict some numeric values and data is labeled, you'll go for the regression algorithms, sure shot. And if you have to divide your data into categories, then you will go for the classification problems, classification algorithms. So I hope till now, from the starting till the end, you are clear with wherever you write some research paper or you solve any problem, you should be clear with whether the problem can be solved using machine learning or not, or it is under the category of supervised, or in supervised also, you'll apply regression algorithms or you will apply classification algorithms, right? I hope I'm clear with the terms. So this is, I have already explained you with a very basic example, what is regression and what is classification. Now, unsupervised, what is unsupervised? You know very much clear now. Whenever someone asks you, you should be clear. Unsupervised means machine is not trained under supervision, but that is not a very technical answer. Not under supervision means data is not labeled. Data is not labeled means corresponding to inputs, you are not having the predefined outputs. It means what? You are just giving the raw data as an input. Machine will find the hidden patterns and accordingly group the data, right? So that is called clustering. Now, so according to the patterns, it will group the data. Like I have given you the very basic example with that fruits one. I hope you remember that I have given this data. Now, according to the pattern, it will analyze the patterns and it will group that these are the most similar. These are the most similar. These are the most similar. So these are clustering the data points into different clusters. So clustering algorithms can be applied to such classes where you are not having predefined classes. Please note there is a major difference between classification and clustering. In classification also you are having groups. If you remember classification like COVID positive, COVID negative, you are having groups there also. And in clustering also you are having different groups, but there is a difference. In classification, you were already having classes predefined that COVID positive and COVID negative, two predefined classes are there because data was labeled. But in unsupervised, I'm not having predefined classes. I'm not having predefined outputs for the inputs. After analyzing the patterns, I'm coming to know three classes will be formed. These will be apples, this will be mangoes, this will be pears. So this is the difference between classification and clustering. Clustering is the part of unsupervised. Data is not labeled. Outputs are not there for predefined inputs. And in supervised classification, classes are already predefined. And in clustering, on the basis of patterns, classes are being formed. So that is, we are grouping the data into similar points. Here you can see here also another use case scenario where you can see for customer segmentation. These are one set of customer who buy some products. These are another set who buy some products. So we have segmented our customers on the basis of their patterns, on the basis of their purchasing history, on the basis of their what they are browsing, what they are picking, what they are doing. On the basis of their similarity patterns, we have grouped them into different groups. So that is what we call as classification of the customer segmentations. Customers are segmented into different goods groups based on the basis of their purchasing history. So that is called clustering, right? So this is one part of the unsupervised learning, clustering, where we are segmenting or grouping the customers. We are trying to find out the audience into different customers. Like it can be, I generally watch action movies. So action movies will be into one group. I want thriller movies. So that will be in the second group. I watch comedy movies. So comedy movie users will be in the third group. So according to the pattern, I'm dividing the customers into different groups so that I can suggest them. I can suggest them action movies because only then my revenue will be enhanced. So this is called clustering, is part of the unsupervised machine learning. I hope you are clear. What is unsupervised, what is clustering, and what is the major difference between clustering and classification, right? Part of unsupervised is association. What is association now? I'm trying to find the correlation between the customers. Like the customer who is purchasing bread, milk, fruits, and wheat. Say another customer is also purchasing these four products. If a new customer purchases bread, then what most likely he'll purchase? If he's purchasing bread, then most likely he'll buy milk also. So this is the correlation between the customers. Whenever I buy bread, most likely I'll get jam. You can buy jam also, you can buy milk also, you can buy butter also, you can buy egg also. So association is again part of the unsupervised learning. I'm trying to develop out the rules, and on the basis of that rules, I'm trying to learn new rules and giving the predictions to the users. So this is called unsupervised machine learning. So unsupervised consists of two parts. Your problem is of clustering type or your problem is of association type. So you need to check out your research problem. Machine learning, yes. Unsupervised, yes. Clustering or association, you have to go through that. What sort of problem is that? What is the nature of problem? What sort of data is there? You have to check out that, right? So this I have already explained with the help of chessboard example. If you are using the correct action, you are taking the correct actions, you will be given the points. And if you are doing some wrong action, you will be given the penalty. That is called reinforcement learning, right? In nutshell, I'll conclude my presentation for the session. So my motive was to make the term simplified in your minds. Machine learning has basically three components: how you are representing, how you are optimizing, and how you are evaluating. Now, what the representation means? What models you will be building, that we have seen: supervised, unsupervised, reinforcement. What you will go for supervision, what algorithm you will opt in unsupervised, what you will opt for reinforcement. So that is how you will represent, how you will optimize them, whether you will be applying some gradient descent, whether you will be applying some regularization methods, how you will be applying some genetic algorithms, how you will further tune them. The data, first how you have to decide according to the problem, further how you will optimize, and further how you will evaluate. Like I said, for a kid, I evaluated manually, checked the answers, they were correct, means the accuracy was of the kid was correct. But how you will evaluate the machine, how you will evaluate accuracy of your model. So different metrics, different measurement criteria are there. You will evaluate the accuracy, you will evaluate the precision and recall, you will calculate the mean square error. What you will do, you will find the entropy. So these are the different evaluation metrics. In the further sessions, you will be getting hands-on exercises on every algorithm, how to build, how to evaluate, how to represent, right? So this is in a nutshell what machine learning is. You have to be very much clear with these three aspects, right? So why machine learning is the future, you should know. The main reason behind that is why it is on boom, why it is a trending technology. You can see this data, that data is increasing exponential. And from that data, within a short span of time, we need to find out the relevant information. So you can see from 2010 to 2020, how the data has been increased from 130 to 40,900. 50 times the data has been increased. So due to the increase, due to the exponential volume of the data on the web, we are moving, we are evolving, we are increasing to utilize machine learning algorithms to make our machines intelligent, to make our machines learn so that our complex tasks can be done easily. I hope I'm clear with all my terms. Thank you for the session. I hope you all enjoyed. If you're having any doubts, you can put up in your chat section. I would love to take them.
Any doubts you can put up in the chat session.
Thank you all for hearing it patiently. So if you're having any doubts, you can just put up in the chat box. I would love to take. Thank you. Thank you so much.
Thank you so much, Anu ma'am. Thanks a lot for the session. I hope everyone enjoyed the session. Now it's the time for a short break, and we'll join back at 2 o'clock with another explanatory session. Thank you so much, everyone.